Okay, so diving right in, we've received this source material, and it's really focused on, bringing mathematics into agricultural technology.
Yeah, exactly. It's exploring how these fundamental math concepts get applied, like right out there on the farm, not just in textbooks.
And what really jumped out at us looking through these sources was this focus on using calculus,
Mm-hmm.
specifically differentiation,
Mm-hmm.
for monitoring solar panels. And these aren't just any solar panels, they're part of precision agriculture setups.
Right. Precision agriculture, which is, all about using tech sensors, data, automation to make farming much more efficient, better yields, less waste.
And keeping the tech itself, like these solar panels, running perfectly is, well, it's obviously key.
Absolutely critical.
So for this deep dive, our mission, if you like, is to unpack how a concept like differentiation, something you might be sort of grappling with in class right now, is actually used.
Yeah, how it becomes this practical tool.
Exactly. For understanding and monitoring the real-time performance of solar panels out in the field, connecting that abstract math to something really tangible.
And real-time performance is the key phrase there, isn't it? It's
Mhm.
not just about, say, how much energy the panel made all day. It's about knowing how its output is behaving, like right this second.
Right, because it's not constant. The output changes all the time.
Yeah,
Sun moves, clouds appear, maybe dust builds up.
all those dynamic factors.
Yeah.
And differentiation, well, the derivative, mathematically speaking, it's the tool that measures the instantaneous rate of change, how fast something is changing at a specific point in time.
Okay, so here's where it clicks, I think. If you have data, maybe from sensors,
Yeah.
showing the panel's power output over time,
You can model that as a function, yeah?
and then calculating the derivative of that function,
Yeah.
at any given moment, it tells you precisely how fast that power output is going up or down right now.
And that is just crucial for monitoring in precision ag. Think about it. Just looking at the total power might show a problem, but maybe only, later on. But using the derivative, a sudden weird shift in the rate of change, like the sun's climbing, output should be increasing fast, but suddenly that rate flattens or drops.
So that's your immediate flex.
That's your immediate signal, yes. Instead of waiting to see the day's total is low, you can spot and issue a bad panel, maybe unexpected shade, the second it affects of the speed of energy production.
It lets you be proactive then.
Totally proactive. You can set alerts based not just on the power level, but on how fast that level is changing. Is the rate way off what's expected for this time, these conditions, that deviation in the derivative? That's the alert.
It's like your car's warning light coming on immediately when something's wrong with the engine's performance.
Yeah, good analogy.
Rather than just realizing hours later you burned way too much gas, you're watching the performance speedometer.
Exactly. And in farming, especially precision ag, where every bit of energy counts and downtime costs money,
Right.
getting that instant insight from calculus, it's incredibly valuable for catching problems fast, keeping the whole system efficient.
So wrapping this up, what does this really mean for you, maybe listening to this while studying calculus?
Well, the big takeaway, I think, is that these tools like differentiation, they're not just abstract math problems.
No.
They give us a powerful way to see and analyze things changing in real time, a lens on dynamic systems.
And being able to measure how things are changing second by second is just essential for managing modern tech like these solar panels, making sure they run efficiently, especially somewhere demanding like a farm.
Yeah. So maybe a final thought to leave you with. As you encounter these seemingly abstract mathematical ideas, calculus, stats, algebra, whatever it is, consider how they might be quietly working behind the scenes. Powering technology, driving innovation, often in places you wouldn't even think of. They're constantly giving us new ways to understand, interact with, and optimize.